Hello students and welcome back to another video of this channel, and today we are going to discuss about two questions related to the same topic. Okay, with the same concept we can like explain both this question, and we will do it very quickly. And from this, if you get the concept, you can do your homeworks also, right? Your assignments also, that whatever question about this concept you can easily do it. Okay, so let's start. So here you see the reagent is given as concentrated HNO3 plus concentrated H2SO. As soon as I see this, I know that it is a aromatic electrophilic substitution reaction. It's an aromatic electrophilic substitution reaction. Now in aromatic electrophilic substitution reaction, you will get a electrophile. And what is the electrophile? From here you will generate, that is NO2 plus. I hope you know the mechanism. I am not doing the mechanism for NO2 plus, then the video will be long. That is not our topic of discussion today. Okay, if you want to know about how this electrophile is generated, so for that a separate video is needed. Okay, that how the electrophiles are generating, like NO2 plus or CH3 plus or SIL plus, like that. Okay, Cl plus, like that. And the thing is that to notice is that here I have been given with two benzene ring, and the benzene ring also some positions are numbered, and you have to tell at which position the substitution will take place. So this is about the position at which the reaction will happen, the reaction will take place, you have to tell. For that we have to know the concept of activating group and deactivating group, and I have already made a video previously about this activating group and deactivating group. In that video also I have discussed about these things. Okay, so just let me write this molecule again. So it is given a benzene ring, and with this benzene ring there is a oxygen, and then probably there is a C double bond O, right? Just let me check. Okay, no, it is just only CH2 is given. Okay, it is just given as CH2. Okay, yes, CH2 is given. So let me just omit it. Yeah. CH2, and then you are having another benzene ring. Okay, the first thing what I will do is that this oxygen is having lone pair, and this lone pair can initiate the resonance. How? This can go here and this will go here. If you do this, then you will get a resonance like this, a resonance canonical structure like this. This will be a O, CH2, and this will be as it is. Sir, why? Because I didn't touch this part, so it will be as it is. Now this pi bond is breaking, and that negative charge has been taken by this carbon atom. Okay, and if you do the further resonance, you see you can get the negative charge here, and if you do the resonance, you will get the negative charge here for the subsequent canonical structures. We don't need to do that. After this, after doing this, we can say that this ring is actually an activated ring. Sir, why it's an activated ring? Because as it is adjacent to this oxygen, and this oxygen is showing plus R effect. And why plus R effect? Plus R effect means electron pushing by resonance. It is giving the electron by resonance, and in this ring the negative charge density is increased. Okay sir, as negative charge density is increased and ultimately you want to react this with NO2 plus, obviously the reaction will be more feasible now. Okay, so the ring is activated, but the problem here is the ring is not activated at all the positions. Sir, which positions are more activated? This position is more activated, this position is more activated, and this position is more activated. That means that you are trying to say that ortho, para, and these ortho positions are more activated than this meta and this meta position, right sir? Yes, because the meta positions are not getting any negative charge during resonance, but the ortho position, this para position and this ortho positions are getting a prominent negative charge during the resonance. That means these ortho and para positions are more activated than the meta position. Okay. So the first thing is the ring is totally as a whole, the ring is activated, but the ortho and para positions are more activated than the meta position. Sir, what about this ring? This ring is not that much activated. Obviously, this ring is activated by the hyperconjugation of this CH2 group. It's activated, but always resonance is the most predominating factor. Resonance is the most predominating factor. So first thing first, eliminate this ring. In this ring, the reaction will not take place. Reaction will take place in the activated ring. And also in the activated ring, ortho or para position, the reaction will take place. In the ring, ortho and para position, the reaction will take place. So you can either get this position, this reaction, you can either get this molecule, or you can either get this molecule. See, I have added the NO2 as the ortho position, and I have added the NO2 as the para position. But which one is major? Obviously, the para product is major, because in the ortho position there are some repulsion and all these things. Also, para resonance chemical structure is also stable, more stable than ortho. All these things are there. So the reaction will take place at this para position. From here, you have to add the NO2 group. So your answer will be option number B. Option number B will be your correct answer. You see, this ring is eliminated. In this ring, the reaction will take place, and reaction will predominantly takes place at the para position. And para will be your major product. You see, they are asking for the major product. And if they ask for the minor product, then this position or this position. So 3 will also be your answer. 3 and 1 is your answer, but 1 is the major product. So I hope you got it right. Now with the same logic, we will do this question. Sir, this question, it looks a little difficult. The molecule looks like a little complicated. Not at all. It's so easy. You see, first of all, you have to identify that what is your electrophile. Sir, electrophile is, it is given NO2 plus and BF4 minus. That means that electrophile is NO2 plus, right? Yes, electrophile is E plus. E plus is your electrophile. So your electrophile already is identified, and that is NO2 plus. Okay, so in the reaction, NO2 plus will be added to the benzene ring. Now here is also the problem is the same, that I am having say 2 benzene ring. So what I can do? So what I can do is that I will write this molecule again. Let's see what happens. So if you have a sound knowledge about resonance, then you can easily tell me, sir, this nitrogen is having lone pair. This will initiate the resonance, and you will get a negative charge here. After resonance, you will get a negative charge here, and after resonance, you will get a negative charge here. That means we can easily tell that this ring is actually a activated ring. This ring is actually a activated ring. And said, if the same thing I do for this molecule again, but for the next benzene ring, so let me write this molecule again. Sir, for this carbon, as it is not having a lone pair, but it's a pi bonded with the oxygen, so I can do a resonance like this, and that means I'll get a positive charge here. If I do, I'll get a positive charge here, and if I do, I'll get a positive charge here also. That means I already got my answer, that this ring is deactivated ring. This ring is deactivated ring. Sir, why? Because you see, in the first ring, there is a plus R effect of NH group, right? There is a plus R effect of NH group. Plus R, why plus R? Resonance, and it is pushing the electron by resonance. Here, it's the minus R effect of this C double bond O group. Sir, minus R, why? Because it is taking the electron by resonance. So who is activating, who is pushing more electron? Sir, this one is pushing more and more electron. This one is pushing more and more electron. So which ring you will take? I will eliminate this ring. I will take this ring, sir, and also I'll take the ortho positions or the para position. But sir, in ortho position there will be some repulsion. Always your para is the major product. So if that is the case, then what will be your answer? Your answer will be like this is the molecule. It is NH, then it is C double bond O, and if this is the case and you react this with NO2 plus BF4 minus, then your molecule, your product will be, you have to add this NO2 group at this point. You got your answer. So this will be like this, NH C double bond O, and this in position you will add the NO2 group, and that will be your answer. So that means that what is matching? Option number C is matching, and this is your answer. So that's it. So you see, only one concept we have done. What is the concept? The concept is activating group or deactivating group. Activating group or deactivating group. Okay. We have done the concept of plus R, minus R. We have done the concept of orthopara directing or meta directing, right? So with this we can do this question. Remember, this is a very important topic of class 11 hydrocarbon chapter. You can surely get questions from here. It can be in your board exam or it can be in your entrance exam, but definitely you will get a question from here. Okay, this is a very important topic. Please revise it, and if you have any problem further, you can let me know. Okay, and for that I will also try to give you a homework. If you want to do this assignment, you can do, and if you don't, then like if you didn't get this, we'll discuss in the next class. So probably this is the question. This is a previous year question. I have to check which year it was, but yes, yes, concentrated HNO3 plus concentrated H2SO4. So you do the product and you can let me know in the telegram, or otherwise I will do it if you have any problem. Okay, so with this I will end this session here, and thank you so much for watching this, and we'll meet in the next class. Thank you.